Hello and welcome back. This is part 3 of finding the number of solutions to an equation. I'm going to begin here by writing down the first example, which is going to be 5 times the quantity of x plus 3 equals 5x plus 3. So again, we're going to begin by solving these questions the same way. We are going to begin by drawing a wall down the middle of our equation, separating the left side from the right side. We are then going to look and see if we have either any like terms to combine or to see if we can clear some of these parentheses out. In this case, we scan the problem. There are no like terms, but there are parentheses that we need to get rid of. We do this by applying the distributive property. We are going to distribute the 5 times the x and get 5x. Distribute the 5 times the 3 and get 15. We are now going to bring everything down, or as I say in class, let the chips fall. Okay? And now what we're going to do is we need to isolate the variable x, or get x by itself. In this case, we notice that we don't have a smaller x because they're both the same. They have the same value of a positive 5. So it doesn't matter which x you move over. We move it over by performing the opposite or the inverse, and what we do to one side, we must do to the other. Now I'm going to end up getting 0 here for both of these, and then I have 15 equals 3. I'm bringing down what's left or letting all the chips fall. So if you notice now, this looks a little strange because there's no x. Normally we're used to seeing x equals an answer. Okay, so we know it's definitely not going to be one solution because we don't have x equals a number. We know it's not going to be infinite solutions as we looked at in part 2 because the left side here does not equal the right side because 15 is not equal to 3. That's an untrue statement. When we end up with an untrue statement, when we're solving equations, this actually indicates to us that there is no solution. No solution. And just as with the other examples, we were able to prove this by doing a check. In this case, we are going to check this by picking any integer. Okay, so I'm going to first begin this check by rewriting the original question, rewriting the original equation. And again, we can choose any integer, and no matter which integer we choose to sub in, it doesn't have to be an integer. We're just choosing an integer for easy math purposes. We can choose any rational number, meaning any decimal, any fraction, or any integer. But no matter what integer we choose here when we sub back in, nothing is going to work. And that's why we can say, when we end up with the left side not equaling the right side, that we have no solution. Meaning, no matter what solution, like x equals 5 here as an example, that we sub in, it will never check out. It will never work. So I'm going to prove that right now by using the integer 5. So wherever I see x, I'm going to replace it with 5. Same thing here. Wherever I see x, I'm going to replace it with 5. Remembering to draw your barrier or your wall to separate the left side from the right side. So now I'm going to solve this expression or this equation here. So I'm going to look at this. I always have to perform what's on the inside of the parentheses first. 5 plus 3 is 8. And then I'm going to bring down the 5, making sure I leave that 8 in parentheses. And then here I'm going to multiply because a number touching parentheses indicates multiplication. So we have 5 times 5, which is 25, plus 3. And when I multiply, because a number touching parentheses indicates multiplication, I end up with 40 on the left, and I end up with 25 plus 3 is 28. As we stated or noticed above, the left side does not equal the right, and the same thing occurs when I perform my check. The left side does not equal the right side. And we know that's a problem because, again, there is no solution or there's no rational number that I could sub in to make this equation true. And this is an example that we looked at in part 3 for no solution. So just to recap the 3-part video that we have worked through the last couple weeks here and that we've been working on in class, we have one solution, we have one solution, so we're going to recap. We had one solution, which would look something like this, x equals 5, or x equals 10. Okay, that's when we actually get an answer. We like that. We're so used to seeing that. We're comfortable with that. It makes sense to us. Okay, then what we end up having is infinite solutions, and that occurs when you end up with the left side equaling the right. So you might end up having 5 equals 5, or 3x equals 3x. Okay, but when you notice that the left side equals the right side, then you're going to say that there's infinite solutions, which basically means that no matter what you sub in when you check, you can choose any rational number. Again, rational number meaning integer, decimal, fraction. No matter what one you choose, your check will always work. And lastly, what we just did in part 3 was no solution. And no one likes this because it looks so strange. It's when the left side does not equal the right side. As indicated in the example above, 15 does not equal 3. Okay, and again, what this basically indicates to us is that no matter what you sub back into the check, nothing is going to satisfy the equation. Nothing is going to work. So just to recap, videos 1, 2, and 3 over the last like month or so that we've been working on this class and that I've been posting these videos, we can clearly now see that we can have 3 possible solutions. Either one solution, which is what we're comfortable with, infinite solutions, or no solution. Thank you, and stay tuned for another episode next time.